everyone. We are live from reInvent. I think some of you were able to listen to what we were talking, so it was not part of the plan, but it's good. At least you saw how we were preparing for this. So this is a show we do every few weeks. We have a weekly cadence, and we teach people how you can build different projects by your own. And my name is Anupam Mishra. I was one of the pieces of this show. And then we have been doing it for probably more than 6-7 months now. And I've been with Amazon for about 10 years now, worked on different teams, and really love sharing what we learn from different people.
Yeah.
Todd, do you want to introduce?
Yeah, hi, Todd Varland. I'm part of the global business development team for IoT, perfect topic for doing robots. And I've been doing the show in 2017 with Anupam and a few times with Jeremy. And so this year in 2017, we've done, what do we think, about a dozen episodes?
About a dozen shows,
About a dozen shows. And it's been really fun. We've built robots. We've built voice interaction. We've been really kind of progressing the whole year. It's been really fun. So, Jeremy, you want to tell us about the a little bit about what happened at the Japan event?
Absolutely. So we had a lot of fun.
You want to introduce yourself?
Oh, yeah, sure. So if you guys don't know me, my name is Jeremy Wallace. I'm the solutions architect here at Amazon Web Services. So I was lucky enough to head over to RoboCup this year with Anupam, and we saw some of the most incredible innovations in robotics and AI, and really got us inspired, I think. And we started building things. So it's been really cool to watch Todd and Anupam. They've been building out this new robot that is able to do some really cool stuff. Yeah, and we're really also excited to have this at the Developer Lounge here at reInvent. So that's been super exciting to just hang out with you guys and show customers how this works.
Yeah, that was great, actually. We learned a lot at Japan, and we put some of that in use. So we're going to talk about this physical device. It looks like a Roomba, but it's iRobot Create. And we're going to share more about what it does and what it is. But Todd, do you want to start with what are we doing in the show so far?
Yeah. So far this season in 2017, the idea is to kind of create a semi-autonomous robot. And so what we have here is, like Anupam said, an iRobot Create 2, which is a STEM platform for developing robots. And then we've got a robot arm that we printed here, 3D printed. We're going to show the URL for that. It's powered by a Raspberry Pi. It has a Seed Studio far-field array mic on it, so we can give it voice commands. And then it's got a camera here that we use to search for images using AWS recognition. And so we have a short time frame to do this particular episode, only about 20 minutes or so. So we're going to quickly walk through all the different pieces and parts of this robot. Do you want to show the video first of?
Yeah, so I think
people can get a sense of what this is.
We actually wanted to show you a working demo of this, but given the space constraint here, I'll just show you the video. Can we switch to my screen? So I'm going to play a file.
So maybe we could talk over what it's going to do.
Yeah, so what it does is, this is a standard, very similar to Roomba, but it's called Create. What it does is it can go in different directions. It's scanning the field, and it's looking for different objects. So whenever you'll see its hand will go up. It's taking a photo in that position, and it's trying to see what is in the photo. And if it finds an interesting object, which we can tell it what is interesting, it tries to align itself so that it can grab that object. So right now, what it is doing is trying to see, okay, this cube looks like something I'm looking for. And it's trying to align itself. It moves forward, it moves backward, it does some left and right movements, and it's using recognition to identify what is visible in this frame right now. And once it sees that, it goes there and grabs it. And once it has grabbed it, brings back to the user. So think of it as a robot which can go anywhere. It can find out what is in the field, and once it finds that object, it can bring it back to you. So it's a very simple use case right now, but we think there are a lot of possibilities of expanding it further. For example, we can think of grabbing real projects like get a drink, get a piece water. Cool. So I think Ben just joined us. Hey,
Yeah.
Ben, do you want to introduce yourself?
Yeah, I'm Ben Kehoe. I'm a cloud robotics research scientist at iRobot, and I brought the Create along.
To the
Awesome.
party.
Yeah.
So it took us a lot of days to make it a functioning device, and Ben helped us a lot with how Create works and what are the different things it does. So it'll be good to know, Ben, from you. What is the purpose of Create? Like, why did iRobot create the Create, and what can people do with it?
Yeah. So Create is a product that's built on remanufactured Roombas. So we strip all the vacuum guts out, and we provide an interface over serial port to be able to control the robot and read all of its sensors. So you can drive it around. It can form a mobility platform for other robotic pieces like an arm or whatever kind of sensors and actuators you want to add on top of it. And we do this because STEM education and makers, the maker community is an important passion of us, as iRoboteers, but also as iRobot as a company, that we support that. And so the Create is part of those efforts.
Yep. And if somebody has to create something similar, how would they do it?
Yeah, so you get a Create, and you say connect a Raspberry Pi like we've done, and there are various libraries out there that allow you to program and connect to the Create and control it. How we tell it to drive forward and turn, and we can read when it bumps into things by reading the bumper sensor, and so all of that information flows out from that serial port.
Nice.
Yeah.
So one of the things we're going to show you today is how we created this. The purpose of the show is to help you recreate whatever we create. Today we have limited time, so we'll go fast, and hopefully we'll be able to show at least at a high level how this works.
Yeah, and before we do that, there's two other members of the extended team, Kevin Huang and Seb Menon, who did an awesome job putting the physical electronics together and doing a bunch of coding. So we want to give a shout out to those two guys. The stage is too small to bring them on. So anyway, two more extended members of the team.
Yeah, so we're very happy with what we were able to do. Hopefully we'll be able to extend this into something even bigger. So I wanted to show you at a high level what are the different things we are using here. So can we share my screen? Okay, so I'm hoping you can see my screen right now. So there are a lot of projects which iRobot has. So if you want to get some inspiration, just go to this link, iRobot/about iRobot STEM Create 2.
Yeah, if you search for iRobot Create,
Yeah.
you should be able to find this page.
Yeah, so there are a lot of projects which
DJ Roomba,
Yep.
or
a
DJ
lot of-
Create rather.
Yeah. And how much are they?
They are
Ben?
$200
Okay.
from our online store.
Okay.
Yeah, so this is their website. You can look at it. What are the different things you can do with it? So there's a library which you can use with Create. Let me show you how that works. So I'll go to my search engine and look for GitHub Breezy Create. Breezy Create 2. So this is the library which we used. As Ben said, there are a lot of other libraries. These are like open source libraries people have written, so they can talk to Create. But this is something we used. I would highly recommend you just check. There are like 4 types of things you can do here.
Yep, this is in Python.
Yeah,
Yeah.
Python code. So you just say move forward, move backward, for how long you want to move it and at what speed you want to move it. And similarly, you can say turn left or right and at what speed and at how much time you want to move. So those are the core controls we are using besides the sensors.
Yep.
Right?
And if there isn't a library that's built in the language that you want to, I don't know that we, for example, have a Go library that the community has built. All the specifications of the serial communications is documented, and so you could build that library yourself.
Yep, so once we have the create piece figured out, once you know the libraries, you have this create which can move in different directions based on what you want to do. Now once we had that, we did some work to put this arm on top of this. Todd, do you want to talk about
Yeah.
it? You printed this.
Yeah, so yes, I printed this at home on my Lulzbot Taz 5 printer. Go love that device. So So this is an ARM mechanism that we've used a few times now. We kind of continue to improve it. It can be found on our AWS Labs GitHub site. If you just go to, if you look for Mini Fulfillment Center, this site that Anupam's showing on screen, all the STL files necessary to print this, you can download and then either send it to a service like fictiv.com, that's fictiv.com. They'll print it for you, or if you've got a 3D printer, you can just print it yourself. And then we're using a series of servos from a company called Robotis. And so, and I think Anupam's going to show that. This is the company Robotis. These are really awesome, smart servos. And then another shout out to a colleague, Brett Francis, who wrote a Python binding against these Robotis servos called, excuse me, Servoed. Do you have that URL, Anupam?
Yep.
So these are basically the, if we were going to create a recipe for building this robot, these would be all the ingredients. From kind of the bottom up would be the Create 2, and then a Raspberry Pi, and then the STL files, the Robotis servos, the Servoed library, and then of course a Pi camera, and then recognition, right?
Yeah. So
AWS
far we haven't talked about how AWS is powering it.
Yeah.
So you can do a lot of things with the cloud robotics. You can let the robot do a lot of local things and then use power of cloud to make it more intelligent. So we are using AWS recognition, which can detect objects. It can tell you what is in a given image. It can also tell where a specific object is. So for this example, we are finding where a specific celebrity is. So somebody could say Tom Cruise or any other celebrity.
Or Andy Jassy.
Or Andy Jassy, and then say, where is the nose of this person? So it can even tell in a given image where the nose is. So we are trying to pick we're trying to create a bounding box around nose and picking that object. So there's a lot of small code which we have written to make it work. Most likely we'll not be able to show you everything, but at a high level, we do want to give you a gist of what it looks like. So let me share some of the pieces. So the first piece is recognition, and first I'll show you how recognition works.
Really simple API.
Very simple API. We have a function which we created in Python called call_recognition, and it takes a celebrity name. And then what it does is it first takes an image. It opens an image which was already taken by a Pi, and then once it takes it makes a call called recognize_celebrities. So it sends all the payload of the image to this API, and this API tells which celebrities were found in that image. So once the celebrity is found, we grab the response and we look for the faces, and in the face we find the celebrity which we were interested in. For example, it could be Tom Cruise, or it could be Andy Jassy, or Jeff Bezos, whoever. And then once we find that, we return the nose position back to the caller.
Which effectively gives us the center of the image.
Yeah, so if you look at this, what it is doing is it's in this position, it takes a photo below it, and from that frame it sees what celebrities are below me, and whatever is there, it tells the nose position of them as well.
And that's because the camera is
Here.
So when it's in this horizontal position, it's getting a nice, vertical top-down view.
Yeah.
Yeah, and then one of the challenge we had was, how do we let it scan the whole path? So think of it as like a normal Roomba. If you have it in room, how do you make it scan the whole room? We thought of different approaches, but we went with a very simple one. It just it starts going in a single direction, as long as it doesn't hit a boundary or some kind of obstruction, and then it turns in a random direction.
Taking an image about every foot or so, right?
So we calculated how much is this image size and how much it should move so that it's covering the whole area. So it could take a foot or so, and then again move 1 foot, and then again take the image. So it keeps doing that, and then eventually it will hit a wall, and then it turn back. So we are scanning the whole area, and we are essentially dividing the whole area into 1 foot by 1 foot squares, and we are looking at all those squares and checking what is in that square. And once we find it, what did we do? How do we align this?
Yeah. So then what we do then is like Anupam was said, is we take an image, we find out where in that XY coordinate the center of that image is, and then we do a quick calculation. We did some whiteboarding a few weeks ago and figured out the math, and then send instructions to the create base unit to move either a little bit left or a little bit right, a little bit forward, a little bit back, whatever, to get the block in a position where then we expect the to pick up, and then we just execute a command to the Dynamixel servos through servoed to just grab the block and pick it up. And then I think Seb and Kevin then even have the create play a little tune because it'll play
music.
Yeah. So
MIDI music.
Yeah.
So
it grabs it and plays a celebration
yeah.
song.
So anyway, it's pretty basic, but it's pretty awesome that you can have basically a mobility platform for $200. And so I think we were discussing amongst ourselves, we want to create a telepresence robot for the office. Would be really fun. So you can work from home, and if you have to attend a meeting, you just check the robot out of the base station and send it to the meeting, and with a little stand on it.
You know, literally, that was one of our business units in the past.
Okay.
Had, fleets of robots, telepresence robots, that you could just say, my meeting is here at this time, and there's a fleet of them. It'll select which robot, send that to the meeting room, and then dial you in.
Nice.
Just
I love
it was great.
Yeah.
So hopefully this is inspiring somebody to create their own.
Yeah, one more thing we did when we created this show, we thought we should go in small steps. The first season we were creating a simple robot which can just talk to cloud. So we would move our hand and robot will replicate those hand movements. In the second season, we create an AI-focused robot where you can talk to the robot and ask it to do different things. So I think in future we want to have a speech recognition in this using Amazon Lex. And we can talk to it and say, hey, get me a glass of water or bottle of water. And hopefully it can go and recognize where the bottle of water is and get you that bottle of water.
Yep.
So that's hopefully our next milestone.
Yep.
Now I think there are like a bunch of more code. I'm not sure how much we should go in the code.
Yeah.
But the way we do it is we release some open source packages, and then people can follow them and work on them. So right now this is not open source. We are still working on that, but hopefully in next 1 or 2 weeks we'll release what we have. You can just check out AWS samples GitHub repository.
So we got a question.
Yeah.
I know you guys probably can't hear me, but can it identify hot dogs?
The question is, can it identify hot dogs?
Yeah.
Yeah.
Definitely. So actually there's a blog which one of my colleagues wrote just to make fun of the HVO stuff. They created a blog where it does hot dog or not in probably less than an hour. So you can create an app using recognition in less than an hour or MXNet. So definitely this can do the same.
Yeah, that was from Dr. Dre.
Okay.
And then grab the hot dog and bring it to you.
Grab the hot dog, yeah.
If you have hot dogs just lying around your floor, this is going to work great to clean up those hot dogs.
Hot dogs, clean up,
Yeah.
yeah.
All right. So Anupam, what's in store for the future?
For future, so I think we've come a long way. Initially, we were thinking we're gonna create a series of milestones where people who know about cloud robotics, they start with season 2. Maybe people who want to learn about AI, they just go to season 2. This is more of giving you a taste of what this program is. We couldn't do everything we wanted to do, but in future, next year, we will have a lot of other shows focused on making more community projects. So community projects means we want the community to work with us. So for example, if some of you have ideas of, hey, why don't you create this? Or I'm working on this cool thing, why don't we work together? So we are looking for those opportunities and collaboration. So we have an email list called AWS-Twitch@Amazon.com. So I'll repeat, AWS-Twitch@Amazon.com. It's listed on our Twitch page as well. You can. I highly recommend you to send emails if you have some cool ideas for us. We are brainstorming every day to do something new.
Yeah. So build on AWS.
Build on AWS. Yeah.
Great.
And ideally with a Create.
Ideally with a Create.
And if you are building something on Create with AWS, we'd love to hear about it as well. So you can reach out to the Twitch folks and they can loop us in.
Awesome.
Yeah. Awesome.
Great.
Any other final questions?
Not much. A little bit about sandwiches. I don't know. I'm sure you guys can do sandwiches.
Sandwiches, yep. Hot dogs.
Oh, well,
Yeah.
this is one of the philosophical questions. Is a hot dog a sandwich?
We'll let the audience decide.
Awesome.
Yeah. Thank you very much for
right,
watching, and
thanks,
we'll see you
everyone.
again.
Cheers.
Cheers.